Okay, today's lesson is section 6.4, Elimination Method Using the Multiplication. It is just like section 6.3, except for you are going to have to manipulate the equations to have opposite coefficients. So to do that, all you need to do is step 1, multiply one or both equations to obtain opposite coefficients for one of the variables. If you will look at this equation, neither one of them have opposite coefficients. But if you look at the y's, if the second equation was a negative 6y, then they would be opposite coefficient. So what we need to do to make it become a negative 6y is multiply the whole equation by a negative 2. So the first equation I'm just going to recopy. And the second equation I'm going to multiply every single term by negative 2. So that's negative 4x, negative 6y, and don't forget to multiply negative 2 times a negative 5 and give me a positive 10. Now, this is just like the section before that. They have opposite coefficients. The 6y's go away. 5x minus 4x is 1x, or x is equal to negative 8 plus 10 is 2. Now, I'm going to plug in x equals 2 into one of the original equations. Does not matter which one, you will get the same answer. I'm going to plug it in the first one. So that's 5 times 2 plus 6y is equal to negative 8. That's 10 plus 6y is equal to negative 8. Subtract 10. You get negative 18, and then divide by 6, and y is equal to negative 3. And there's your answer. And please put it in ordered pair. Example 1b. If you'll notice, as of right now, we don't have opposite coefficients. But let's look at the x's for just a minute. If the second equation was a negative 6, then there would be opposite coefficients. So I can either multiply the second equation by a negative 2, or I can look at the y's. What would be a common multiple of 2 and 7? That would be a 14. So one would need to be a positive 14 and one would be a negative 14. So if I did that, I would have to multiply the top equation by a 2, or excuse me, a 7, and the bottom by a 2. It would be much easier to get rid of your x's because I would only have to multiply the second equation by a negative 2. So that's what I'm going to do. So again, when I multiply negative 2 times everything, that's negative 6x. Negative 2 times a negative 7y is a positive 14y. And negative 2 times a negative 19 is a positive 38. So my x's go away because now they have opposite coefficients. So that's 12y is equal to 48. Divide both sides by 12, and y is equal to 4. Now I need to plug 4 for y into either one of the original equations. You can plug it into the second equation that's already multiplied by negative 2, but it's much better and easier if you plug it in one of the original equations. You have smaller numbers. I'm going to plug it in the first one. So that's 6x minus 8 is equal to 10. Add 8 to both sides. So that's 6x is equal to 18. Divide by 6. So x is equal to 3. So my answer is 3, 4. Okay, let's check this one. In equation 1, I'm going to plug it into the original equations. 6 times 3 is 18. Negative 2 times 4, that's a negative 8. And 18 minus 8 is equal to 10. And second equation, 3 times 3 is 9. Minus 7 times 4 is 28. And 9 minus 28 is a negative 19. And that's true. Example 1C, I need to have opposite coefficients. Now let's look at this. If I wanted my r's to be opposite coefficient, I would need to multiply the second equation by a negative 3. Let's look at the q's. If I wanted to get rid of my q's, I would need the first equation to be a negative 2. It does not matter which one you do. You get the same answer. So I'm going to multiply the second equation by a negative 2. Excuse me, I'm going to multiply the first equation by a negative 2. So negative 2 times 9r is a negative 18r minus 2q is equal to a negative 26. The second equation I'm just recopying. You notice that my q's now have opposite coefficients. So that's negative 15r is equal to negative 26, and negative 4 is a negative 30. Divide by negative 15. So r is equal to 2. Now I'm going to plug in r equals 2 in either one of the original equations. I'm going to plug it in the first one. So that's 9 times 2 plus q is equal to 13. 9 times 2 is 18. Subtract 18 on both sides. So q is equal to negative 5. Now, we don't have x and y, we have r and q. What comes first in the alphabet? It's q and then r. So that is the way we will answer it in alphabetical order. So it's 2, negative 5. Example 2a. Now this is a little bit more complicated. What we need to do here is try to find a common multiple of the coefficients. Let's look at the x's first. What is a common multiple of 4 and 3? 12. So we would want one to be a positive 12 and one to be a negative 12. Okay, let's look at the y's. What's a common multiple of 2 and 3? 6. So we would want one to be a positive 6 and one to be a negative 6. So we can choose to get rid of the x's or we can choose to get rid of the y's. It does not matter. You will get the same thing. Let's get rid of the x's. So we are going to multiply the top equation by a 3. And we would need to multiply the bottom equation by a negative 4. You could also multiply the top equation by a negative 3 and the bottom by a positive 4. That does not matter which one is positive and which one is negative, just as long as you have opposite coefficients. So I'm going to multiply the first equation by 3, and I get 12x plus 6y is equal to 24. Multiply the second equation by a negative 4, and you get negative 12x minus 12y is equal to a negative 36. Now if you will notice, the x's now have opposite coefficients, so they go away. Now I'm ready to add 6y and a negative 12y is a negative 6y is equal to a negative 12. Divide both sides by negative 6, and you get y is equal to positive 2. So now I'm going to plug in y equals positive 2 in one of the original equations. Again, it does not matter which one, you will get the same answer. I'm going to plug it in the first one. subtract 4. So that's 4x is equal to 4. Divide by 4, and I get x is equal to 1. So my answer is 1, 2. Okay, let's check this one. I'm going to plug it in the first equation. 4 times x, 4 times 1 is 4, plus 2 times 2 is 4, which equals 8. So it checks. Equation 2. 3 times 1 is 3, plus 3 times 2 is 3 times 2 is 6, and 3 plus 6 is 9. Example 2b. Let's look at the x's. What's a common multiple, the least common multiple of 5 and 2? That would be 10. So I would want 1 to be a positive 10 and 1 to be a negative 10. Or, let's look at the y's. What's the common multiple of 3 and 5? 15. So I would want 1 to be a positive 15 and 1 to be a negative 15. Because my signs are already different, I'm going to choose to get rid of the y's. So I only need to multiply the top equation by a positive 5 and the bottom equation by a 3 because they're already opposite signs. So 5 times 5 is 25. 5 times a negative 3y is a negative 15y is equal to 30. 3 times 2, that would be 5x. 3 times 2, that's 6x, plus 15y is equal to negative 30. Now, the y's go away because they're opposite coefficients. 25x plus 6x is 31x is equal to 30 minus 30 is 0. Now, do not get that confused with your variables going away. Your variable did not go away. Your constants went away, which is okay. You get 0. So we still have to solve for x. So we divide by 31, and we get x is equal to 0. I'm going to plug in x equals 0 in the second equation. Doesn't matter, you could have done it the first. 2 times 0 plus 5y is equal to negative 10. 2 times 0 goes away. So we divide by 5, and we get y is equal to negative 2. So my answer is 0, negative 2. Example 2c. Let's look at the a's. What is a common multiple of 6 and 4? Common multiple of 6 and 4 would be 12. So I would want 1 to be a positive 12 and 1 to be a negative 12. Or, let's look at the b's. What's a common multiple of 3 and 2? 6. Again, I would want 1 to be a positive 6 and 1 to be a negative 6. It does not matter which way you go. I am going to opt to get rid of my b's. So I am going to multiply the top equation by a 3. The second equation I would multiply by a negative 2 because I want one of them to be a positive and one to be a negative. So I'm going to multiply 3 times everything. So that's 18a plus 6b is equal to 6. Negative 2 times 4a is a negative 8a minus 6b is equal to negative 16. Now, notice the b's go away. 18a minus 8a is 10a is equal to negative 10. Divide both sides by 10. A is equal to negative 1. I'm going to plug in negative 1 into either the first or the second equation. I'm just going to plug it in the second. So that's 4 times a is negative 1. That's negative 4 plus 3b is equal to 8. Add 4 to both sides. So that's 3b is equal to 12. Divide by 3. So b is equal to 4. So my answer is negative 1, 4. Your assignment is page 358, all 7 through 18. This is different from your calendar. I shortened the lesson. So make sure you just do these and make sure that you check your odd answers in the back of the book.